All right, this is Calc 2. I hope you're all in the right place. Welcome to the class. I think it's going to be great. Let's chat a little bit about the syllabus here, and then we can, get down to some business. So this is Calc 2. You will see on the syllabus I am actually teaching two sections of this class. So you all are section 1. And section 2 is right after, like it's the time right after this. And actually there are fewer people in section 2. So if any of you would rather be at that time than this time, I don't know if any of you care, but if you would like to switch over to the other one, that would be totally fine with me. Or even if like on some individual day, if you are late or something and you want to come to the other one instead of this one, that's also fine with me, as long as you don't like all do it. I think the other one has something like 20 students in it, so there's like extra seats. Anyway, you can come to the other one if you want to. It's in this same room just after our class meeting. Anyway, my name is Professor Stecker. That's how you say it. And you can see my email address on the top there. That's the best way to get in touch with me. And this is also the way that I plan on getting in touch with you if I ever need to, make some kind of announcement when we're not in class. So I'm going to be emailing your Fairfield email address, so make sure that you check that regularly. If you don't like checking it, then maybe forward it somewhere else so that you see. I will expect that you see when I email to that address. My office is Bano, which is this building. GR16, that's the ground level, which is below floor 1. And it's on that end of the building. So if you go that way and then all the way down, that's where my office is. You can see my office hours are written on there. Those are times when I will definitely be available to chat. If those times don't work for you, then we can set something else up. But this includes right before class every time. So if you're having questions about the homework or whatever, that's a good time to talk with me. And it says the office hours, you can come down to my office. Or if you prefer, we could meet on Zoom. Like during my office hours, I'm just going to be sitting down there, but I'll also have my Zoom turned on. So if you, for whatever reason, if you'd rather come that way, that's fine with me. Just go to this Zoom link. Sometimes I forget to turn it on because not a lot of people want to do that. But if you come, and I'm not there, I'll get a little notification and I will show up. So just wait a minute or so and I will appear. All right. You can see the class website. That's what this QR code goes to. That is important. You will want to go there at least once a week because that's where I'm going to post the homework assignments. So check it out. That is also, I'm going to be doing, I hope that you can all see okay, I'm going to be doing everything on the screens here. That's because I like to record the notes. So after class every day, I'm going to take everything that I wrote here and make a PDF out of it and post it at this website here. So if you ever miss class or anything, you should be able to get the notes, or just like if your notes are no good, you can always look at mine also. I hope that that's helpful. I am also going to record everything. I don't have any cameras in here, but I am recording even right now. I'm recording everything that I write and also the audio of my voice. So I'm going to post those recordings on YouTube, and you can go check those out. Be sure to like and subscribe. I'm trying to be helpful, in case you miss class or in case you are not very good at taking notes or whatever. There should be all kinds of ways that you can catch up. All right, I hope that sounds good. The textbook there is the Stewart textbook called Calculus. It's the 9th edition, which is the newest one. If you're signed up for the, whatever they call it, the textbook deal with the university, that's the one that you got. You probably got an electronic one. The textbook, I'm not going to be giving reading assignments, but I will be, the textbook is where the homework problems are going to come from, so you will want to get yourself access to the book, or I suppose you could get by if you just mooch off of a friend just to copy the homework problems, but I will leave that up to you. Has any of you been able to access the book? I hope that sometimes there's issues with it, but all right. Some people are nodding. Great. You don't really need to do it until our first homework assignment, I suppose, which will be next week, I think. Okay, the final exam is written right there. We are section 1, so your final exam will be Tuesday, December 16th. Unfortunately, that's like one of the last days of the exam period. I don't make the rules. Like I said before, there are open seats in the other section. So if some of you, like if you live far away, you need to leave before then, it would be okay with me if you took it with the other section, although not everybody can do that. So if you want to do that, that's a possibility. Let me know, and I will give preference to people who, like, for some reason need to leave before the very end. All right, great. Let's just go through real quick the rest of this. The course content, you can see the list of topics there. Hopefully you've heard of some of these. You may have done quite a few of these. Basically, this course is similar in content to the typical BC calculus, like that people do in high school. Although this is like just in one semester, not a whole year long. So we are going to do mostly integrals. So I'm going to assume that like everybody already knows about the derivative. So we're going to do integrals and then sequences and series. Those are the major topics. If you did take the AB calculus, then a lot of that will be reviewed, although I think you probably didn't do sequences and series. So unfortunately, there will be hopefully like just a little bit of review for everybody, and maybe a lot of review for some of you if you did take like an AB calc. By the end, we'll all be kind of at the same point, but I hope that that's all right with everybody. Any questions about what is and isn't in the course? I mean, you'll find out eventually. But. All right. A little thing about the homework. It says homework is going to be due every Wednesday evening, not tomorrow, but we'll start next week. The homework does not need to be submitted during the class meeting. Anytime before midnight on the due date is acceptable. That's what it says. The assignments are posted at the class website, like I said, so you want to go there to get the homework assignments. It says late homeworks without excuse will lose 1/3 credit for each calendar day. So if you're having some kind of crisis, by all means let me know. But otherwise, the homeworks should be done on time. I'll leave it at that. All right, let's turn the page. It says mastery-based assessment. This is weird, so pay attention. Most of your grade in this class is based on topic mastery, and you will see the other thing I handed out is this big checklist. This is the mastery checklist. The idea is that is a big list of all the topics that we are going to be learning for the semester. Like I said, hopefully you've heard of some of these things, although it's okay if you haven't heard of any of these. I hope you've heard of the derivative. Yeah, anyway, all of you have this list, and as we go throughout the semester, you will gradually be checking off the boxes. And I will also be keeping track. This is kind of a nightmare for me to keep track of, but I will keep track of every one of you, all of your little boxes, which ones are checked off. All right? This maybe sounds confusing, but you will like this system. I hope so, at least. If you understand it correctly, I think that you will like this. This is a good system from the student's point of view. Anyway, each student's progress, it says, is tracked in a checklist. And the way that you're going to check off these points is by correctly answering questions about these various things on our quizzes and tests. So we're going to have a quiz every week, which, again, sounds intimidating, but this is actually good news. And then we're going to have a test, one test in the middle of the semester, and then another test on the last day of class, which is different from the final exam. And it says, well, okay, each question on the quizzes and on the exams is going to be specifically labeled as one of these 25 things, all right? And based on how you do on that question, you can get partial credit, but if you get full credit, you're going to check off 3 points. I actually have, I don't know if this is really necessary, but I have a little example here. So for example, our first quiz, which will be next week on Friday, is likely to cover these 2 things, maybe one of these also, depending on how far we get by then. But on our first quiz, you're going to get a question about simple derivatives and antiderivatives and another question about u substitution. And maybe you get like two 2 points on this one and 3 points on this one, right? You should check those off after you get your quiz results. Okay, now if you get 3 points on this one, it means you're done with this one, and on all future tests, you don't have to do any of the U substitution questions, because I consider you to have mastered the U substitution, all right? This one you only got 2 points on. This question will appear again on future tests, and you should try this one again to up your score to 3, all right? If for some reason you just totally bomb this and you get 0 points, it means you got 0 points, but you did not screw your average, because eventually you're going to get this one on a later test or quiz, and then the original 0 that you got just like disappears, all right? The idea here is that what I care about is by the end of the semester, I want you to know how to do all of these things. Now, if you mess it up once or twice before you eventually get it right, that's totally fine with me. And actually, that's the usual way that people learn math, is by sort of doing it wrong a few times and eventually doing it right. So it means that early on in the semester, doing it wrong doesn't actually negatively affect your grade. It just means that you didn't get it right yet. And so you'll have to eventually get it right, but you're not screwing your average by getting sort of points taken off. It's not really points taken off, it's just you didn't get the points yet. All right? I hope this sounds like a good system to everybody. It is a little complicated, but it's not that complicated. All right? So the idea is every week we have a quiz. The quiz each week covers just the stuff that we did that week. It's usually 2 or 3 questions taken from the list. And then on the exams, you get every question on every exam. And so that's your chance to go back and sort of fill in the ones that you didn't get previously. Is this making sense? I hope that makes sense. Yes?
What are the ones with the asterisks?
Okay, the asterisk. Thank you for the question. I'm gonna mention that. Let me just make sure I'm saying everything that I want to say here. So you can see on here under the quizzes what I just said. Each quiz will have questions only from the ones that we did that past week. The rhythm here is every Wednesday is a homework assignment that's due, and then the next time we meet, which is on Friday, you have a quiz on those same topics that were on the homework. All right. Also, it says under the quizzes there, once every 2 weeks, students can make an appointment with the professor during office hours to attempt an old mastery question. So if you don't, like for instance, if I got only 2 points here, this question will not appear on next week's quiz also. You could wait until the midterm. This question will be on the midterm also, when you can try it again. Or, sorry, I don't want you. I don't know what's going on. Okay. You can wait until the midterm when you get to try them all again. Or, as this says, every 2 weeks you can just come to my office and say, I want to do number 5 again, and I'll give you a new one of those. Right? Trying to give you chances. This is why I said we're going to have a quiz every week, but that's actually a good thing. Like from your point of view, you want to have as many tests and quizzes as possible, because those are just like more chances for you to get them right. So I hope that it's not like anxiety inducing to have a lot of quizzes and things like that. These are actually opportunities for you to get the checks. All right. It also says under the quizzes, students will not use calculators or other electronic gadgetry during the quizzes. I'm going to make the quiz questions ones which you will not need to use a calculator for. So there won't be like weird numbers that you have to calculate. You'll get the idea as we do examples in class of what kinds of things. I won't expect you to do anything fancy without a calculator. Okay, the next thing under this business is the deal breakers. This is what the stars are all about. It says, the most fundamental topics are marked with the stars. These are the deal breakers. Here's part of this system that you might not like. You cannot pass the course unless you get at least 2 points on each of those. All right? That means if you get to the end, no matter what your grade is, I'm going to give you an F if you still don't know like what an antiderivative is. All right? That's the idea. So the ones with the stars, you must get 2 points by the end. All right? Now, you're going to get several chances to reattempt them, right? You can try, you'll get You'll get another chance on every exam in class. You can also retry them once every 2 weeks. Just between you and me, for the deal breakers, I'll let you retry them a lot. So if we get to the end of the semester and you're really concerned about this, I'm going to give you lots of chances to fill them in. But I want to make sure that everybody actually learns at least those ones. Some of these other ones, like volumes with shells, it's important, but I don't exactly feel badly if you make it through this course and just like never figure that one out. That's okay with me. But if you never figure out like stuff about the natural logarithm, I got problems. So that's why that's a deal breaker. All right, any questions about that one? Okay, great. As we go along, of course, let me know if this system seems confusing to you. I would be happy to try to explain a little bit better. All right, I'm just going down the syllabus here. The next, it says something about in-class exams. You can see these are just during our regular class time, and the dates are there, October 17 and December 5. December 5th is actually the last day of class, so this is a chance for you to kind of, well, I suppose that's going to be your last chance to check off all the whatever remaining items are not checked off. On these exam days, if, like in the best case scenario, if you're just getting like full credit on all of these questions when you take it on the quiz, it means you won't really have anything to do on our exam day because they will have all been filled in. So these exams are really an opportunity to catch up. If you're already caught up, then you may not have to show up to the exam, or maybe you'll just come and do like only 2 or 3 problems, something like that. Right?
So if you know that you have like, say you have 5 checked off, you don't need to study that topic at all.
That's right. Yeah. The exams, when you do the exam, you only are going to answer the questions that you haven't already checked off. Yeah. That's why it says at the bottom here, I hope you haven't already disobeyed me. At the bottom it says, bring this to your class exams and don't write stuff on it. I don't want you to put like notes on this because you're going to bring this to the test so that you know like which ones you need to concentrate on. Yes. Yeah. Just don't write, stuff that I am expecting you to remember. Although I'm not really big on memorizing stuff, but yeah. Yes?
Wait, so when you get a bad score on one of the quizzes, it doesn't immediately get graded and like go in the grade book, or does it? Or will it go in once we immediately get 3 points, once we eventually get 3 points?
I'm not sure what you mean by grade book.
I think I'm comparing it to high school. But like, so like, say I got like a 1 on one of them.
Right.
Are you gonna put that bad grade into like is that gonna be?
Well, I'm gonna keep track of your big chart. So I have a giant spreadsheet on my computer, and I am gonna type a 1 into it.
Okay.
I don't have to tell you about it. I mean, you can't see that. So.
Okay.
I'm gonna leave it up to you. Like, you should be keeping track of this list yourself.
Okay.
Of course, if you ever are unsure about what your scores are, you can ask me. But, yeah. Yeah, this is something that's maybe a little frustrating about this kind of system. I find that students generally like this thing, but it can be a little confusing. If you ever ask me like, what's my grade right now? I'm gonna say something like, well, you have like these checks and these are not checked. It's hard for me to say like, oh, your grade is 85% or something like that. Maybe this is what you're asking. Of course, you can, at any time, you can just like calculate the average of these scores, and that is your grade. Although, like, right now, your grade is 0% because you have nothing. So, but if you're ever concerned about that, you can ask, and I'll try to give you some idea of if I think things are going well or not for you. Any other questions? All right, the final exam. The final exam is, it says, is cumulative and will be graded traditionally, not mastery-based. So the final exam is just like an ordinary test. There's a bunch of questions and you have to answer all of them, and I'm going to grade it like a normal test. All right. So what I said about like if you already have this one checked off, you never have to do U substitution again. That was only kind of true because this question will probably appear again on the final exam, and you have to do it on the final exam. All right, so there is the final exam that everybody has to do, and it's just totally traditionally graded. And the final exam will cover everything, although practically speaking, it's probably not going to have all 25 of the things on it just because that's too many things on one test, but that's the idea. All right, great. let's get on with it then. So you can see the grading. If you look on the last page there, the breakdown of the grading. Your grade, 60% is based on the checklist. So this I turn into a grade at the very end by just averaging up all the numbers, right? You probably, like by the time we get to the end, you're probably not actually going to get 3 points on everything. I mean, some of you probably will, but as I've done this before, it doesn't always work out that everybody gets full credit on everything. So whatever you did get will be averaged together, and that will be your grade for the mastery portion. And then we have homeworks and the final exam for the rest of your grading. Any thoughts about that? And don't forget about the deal breakers. The deal breakers override everything. Even if you have like an A average, I'm going to give you a big fat F. Realistically speaking, I'm not going to give you an F. You're going to come to my office like every day and try this thing again until you finally get it right. That's what's really going to happen. But that's how the deal breaker works. All right, excellent. There's a little note here about attendance. You'll notice the attendance is not officially part of your grade. And it's true, so there's no like penalty to your grade for missing class. I consider it your own responsibility. If you miss class, it's up to you to do whatever is necessary to make up for that. I've tried to make that fairly easy for you by posting all the stuff that we do. But it does mean that if you miss a quiz day, I will expect you to get in touch with me about that beforehand. If you just don't show up to a quiz and then don't mention it to me, I'm probably not going to mention it to you, and you will have missed that quiz. Like I said before, missing a quiz doesn't screw your average, but it means you missed out on a chance to get these questions right. So in general, I have done, I try to do my best to be accommodating if you have to miss class or whatever, but I am not going to, generally I'm not going to chase after you. If you're, I want you to sort of be responsible for yourself. And if you are not being responsible for yourself, I'm not going to call your mom about it. I'm just going to go home to my own mom, right? All right. I should call my mom more often. Okay. That was the attendance. A little note here about office hours. It says the professor regards visits to office hours as part of the instruction for this course. The idea is just that I hope that you will feel comfortable coming and talking with me about homework or whatever else every so often. It's certainly not required, and you don't have to ever talk to me if you don't want to. But the way that I want to kind of run the class is that I expect that certainly if you're doing badly, you should come and talk to me about it. But even if you're doing fine, I consider it part of the normal interactions for you to come to my office every so often. I say this just because, for me in high school, I don't know how your high school was. For me, I never wanted to talk to my teachers outside of class because that was somehow, not because I didn't like them, but it was it means something is seriously wrong with my life if I have to go talk to a teacher outside of class time. And I hope that is not the attitude that you have. I think for me and for most people at Fairfield here, that is talking outside of class is just part of how an ordinary course is supposed to work. And from my point of view, it's much more interesting than me just standing here and talking to all of you. I appreciate getting to know you a little bit on an individual level. So that's that. You don't have to talk to me if you don't want to, but I hope that you will feel free to do so. All right. There's a little note at the end about counseling services. Did you know we have free counseling? By free, I mean included in the outrageous price that you're already paying. But this is a helpful thing. I know I have been helped in my years with counseling. Sometimes my wife says to me, maybe you should talk to Stacy about that. And I think, yeah, maybe I should talk to Stacy about that. Maybe you should talk to Stacy too about things. All right. I think that's all I have to say by way of introduction. Actually, there's one more thing, but any questions about any of that? I hope that it seems all right to everybody. One last thing as far as business goes, and then we can get down to some actual calculus. One last thing is about handing in stuff. All of our homework assignments, you'll see this in the syllabus, our homework assignments and the quizzes and the tests, I'm going to have you submit them electronically on a website called Gradescope. And hopefully you got an email from them probably yesterday around 5:30 maybe is when I set it up last night. Gradescope. This is an online homework collection platform. It's a website. The way it works, it's very simple. I don't know if you've used it before, but you will, like, for instance, when you do your homeworks, you should write your stuff out on paper just like you would or if you were going to hand it in to me. But instead of handing the paper to me, you take pictures of it with it on your phone, take pictures of it with your phone, and then send the pictures to Gradescope, and that's how I get them. All right? So I would like to make sure that everybody is hip with the Gradescope. I want to do just real quick right now a little dummy assignment. So find the email that you got from them. You should do this all on your phone because it involves taking pictures. You can do it on a computer, but you got to take pictures, so you'll be better off doing it just straight with your phone. Find the email you got from them, which is instructions on how to log in. I want to do this right now just to make sure everybody can do it so there are no surprises when we have our actual first homework assignment. If you log in, you will see the dummy assignment. And I would like you all to do it right now. This involves, your assignment is write something interesting about yourself. You are not going to type this out. You're going to write this on paper, just like you would when you do your math homework, and then take a picture of it and send it in. So I'm going to give us a few minutes. I'm going to walk around just to make sure that everybody is being successful, and then we'll do some real calculus. I find the Wi-Fi in this room isn't great. You might be better off just using your cell connection, but I'll leave that to you. You guys doing all right?
Yeah.
Yeah, it's a little slow. Mm-hmm. Write something interesting about yourself.
Do you care if I write on here?
No, that's fine. Yeah, you can do like a signature or something like that.
Are you ready?
Doing okay?
I'm not sure. I'm not sure it's working. Mine's just not working. It wouldn't let me submit.
I think it's just being started.
Yeah.
This is what happened.
Yeah. No worries.
Doing all right?
Yep.
Yes. I'm gonna wait another minute just to make sure everybody's doing okay, and then we'll go on with it. If you're having like real serious problems, let me know and we can kind of work it out some other time. Okay. There is an app. Yeah, I don't really know what it does.
So we can do that. I just don't think it's working because the that's it.
Oh wait, just kidding. Submitted successfully.
Yeah.
All right, I think I'm ready to get on with it. Any more questions about the business of the class? I think I've talked about business enough. If you've had trouble with the grade scope, I hope you can work it out before too long. I just wanted to do it right now to make sure everybody's okay before our first real assignment is due. So we are going to be doing all the homeworks and the quizzes and the tests on grade scope like that. So that means like when we take our quiz, you should bring your phone and do that thing when you're done with the quiz, all right? I hope it's not a hassle for you to do it this way. I find it's a lot nicer for me. I started doing it that way during COVID so that I didn't like get all of your diseased papers. But I find that even when your papers are not diseased, it's a little easier to handle when it's all electronic. All right, excellent. Let's talk then about some calculus. So I would like to start with some review topics. On our big checklist, the first two things there I said are review, although realistically speaking, some of you may have seen a lot more. I'm going to assume that you have all seen these first two things, and then I'm not going to assume that anyone has seen any of the other ones. But let's talk about derivatives and integrals, just to make sure we're all on the same page here. The first of our deal breakers, derivatives and integrals. You should know the most important derivative formula, everybody knows, is this. Nx to the n minus 1. This is the power rule for the derivative. You use that when you have x to some power and the power is a constant. If you have x's up there inside the power, you don't use this rule. That's something else. But this is called the power rule. And it goes along with the integral power rule. These ones I hope that everybody already remembers. To do the integral, of course, is kind of like the opposite of the derivative. And so the derivative says you move the exponent down front and then you decrease the exponent by 1. The integral is the opposite. That is, you increase the exponent by 1 and then divide by the exponent in the front. So it's that. That's how I'm usually going to write this. You can write x to the n plus 1 over n plus 1. That's totally fine. You've got to put the plus c when you do an integral, unless you forget. You shouldn't forget, though. Okay? For example, if I want to do the derivative of x to the 4, what do you say? Someone shout it out. 4x cubed. Excellent. Great. By the way, I hope that you will feel free to interrupt me while I'm just talking up here. That is the derivative. Usually I'm going to write the derivative with this d over dx, although I hope everybody is familiar with other ways of writing the derivative. dy dx sometimes is used, and also like with the primes, although the primes is not very convenient here because I didn't already define a function f of x. All right, or something like, there are sort of basic tricks you have to do sometimes. The square root of x doesn't look like the power rule because it's a square root, but you transform this into a power. I hope everybody remembers. This is the same as derivative of 8x to the 1/2. And then I can do the power rule. The 1/2 comes down, multiplies on the 8, gives me 4 in the front. And then I subtract 1 inside the exponent. That's 1/2 minus 1 is -1/2. And I would just leave my answer looking like that. If you want, you could write 4 over x to the 1/2 or 4 over the square root of x, although those are not any better than 4x to the minus 1/2. All right? Yes?
So you're okay with us leaving negative?
I am okay with you leaving negative exponents. I am okay with a great many things. In general, if you want to write the answer in a different way than I'm writing it, that's fine. As long as it's still correct, right? But if you are used to writing things in a certain way from high school or whatever, or even not even just writing expressions, but even like doing a problem in a different way than I usually do it, that's totally fine with me as long as you are doing it correctly. You don't gotta write everything exactly how I write it. All right, great. Okay, there's also, let's just do, talk about simple examples of the integral. 3x squared plus 7x plus 2 dx. The integral always has a dx in it, which just sort of indicates that I'm doing the integral using x as the variable. How do we do this one? They are added together, which means I can just go sort of down the list here and do the integral of each part. And then each time I do the power rule. That is, I increase the exponent by 1 and then divide by the new exponent. So this 3x squared becomes 3 times 1/3 x cubed. Of course, you can multiply the 3 times 1/3 will cancel if you want to. The next one, 7x, I imagine this as x to the 1, which means I increase it to a x to the 2. So this becomes 7 times 1/2 x to the 2. And then the 2, anyone remember what happens to the 2 when I do the integral? It becomes 2x. That's because, well, you can just memorize. If I have a constant here, it always becomes that same constant times x. Or if you want to be fancy about it, you can think of this is the same as 2 times x to the power 0. And I increase the 0 to a 1, and I get 2 times x to the power 1. All right, and I put the plus c. This is usually how I'm going to write these. And I would leave it like this. Now, if you want to simplify these various coefficients, that's okay with me, but I don't typically care about that. Unless you have, for me, in my opinion, unless I have a good reason to, I don't care about simplifying stuff. I feel like maybe last year or the year before, you had classes which were based on like, do you know how to simplify stuff? I'm going to assume that you all know how to simplify stuff. You don't have to simplify stuff if you don't want to. All right? That's that. Great. What else? Okay, these are just basically polynomials, what I've been discussing here. One other thing that you should know how to handle is something like, 5 over x squared plus 1 over 3x. How do I handle those? These ones have, they are powers of x, but they are in denominators. The first thing to know is you cannot just go in the denominator and do your thing with this power of x. So inside the bottom, change this to 1/3 x cubed. That's not valid. Anybody know what the appropriate thing to do here is? Yeah? Yeah, right. When you have powers of x in the denominator, you should write them instead as negative powers. So this first one becomes 5x to the minus 2. Notice I'm still writing the integral sign here. That's because I didn't do the integral yet. This is not the answer. This is just a simplification, rewriting the original thing again. And then what about 1 over 3x? Here's a little trick. 3x to the minus 1. That actually is not correct. Anyone know what's the problem with that? But yeah, because the 3 is down there, you can write the x over here with a -1. If you want to write it this way, you also better put a -1 on the 3. 3 to the -1, x to the -1. That's a little weird. Really, I think it's a little easier to just write it like that. 1/3 x to the -1. All right? That's different from 3x, come on now, 3x to the -1. Of course, that's what you would get if it was something like if it was 3 over x, that is 3x to the -1, right? But if the 3 is also down there, you got to handle that somehow. The simplest way, in my opinion, is just leaving the 3 down there, right? All right, and then etc. Actually, you know what? I didn't mean to give this example because this, if you know something, this integral involves a logarithm, which I don't actually want to talk about. That's one of our topics for later. Would you mind if I just let's put a 4 there. That means a -4 over here. Sorry to do that. Sorry to do you like that. Anyway, I'm not done here. Now we can actually do the antiderivative by doing the power thing. So my final answer is 5, and then I increase the exponent of -2, goes up by 1, it becomes -1. So this is 1 over -1, x to the -1, plus 1/3, 1 over -3, x to the -3, plus c. And that's my final answer. Of course, you could rewrite this in a more simple way if you wanted to, but that's that. All right. Any questions about that? I hope this is familiar to everybody. Okay. The power rule is absolutely fundamental. I hope that all of this seems totally familiar. And then also you will need to know some derivatives of trig functions. There's sort of, you probably at some point learned like a big list of these. Really, I only care about sines and cosines. I mean, there are other ones for tangents and secant squareds or whatever, but for those, I would expect you to just go look them up somewhere if they appear like on a homework problem or something. But as far as what I would expect you to, I suppose, have memorized, like for doing problems on a quiz or a test in class, I will expect you to know the derivative of sine is cosine, and the derivative of cosine is negative sine. And I will just say, look up the others. The other ones may appear on the homeworks. I will expect you to just go find them on a list somewhere. I won't expect you to have other obscure ones memorized. All right. The only other thing about trig functions that everybody should have memorized is, this is not really about derivatives or anything, but you definitely need to know this. That's sort of the most fundamental of all of the random bunch of nonsense that you were asked to memorize about these functions. Other ones are important, but again, I'm not going to expect you to have them all memorized. All right. And I'm going to say, so those are the derivative formulas. There are corresponding integration formulas. They go the other way. So the integral of cosine is sine plus c, and the integral of sine is negative cosine. Unfortunately, these are easy to get them mixed up about where the minus goes and where the plus goes, but you just got to keep it straight. All right. So these are all the things that I will expect you to have memorized. Like I said before, I'm not really big on memorizing a whole bunch of stuff just because it's not a very realistic skill. Like in your life, nobody is going to care if you have memorized the integral of secant squared or whatever. They will care that you know how to figure that out. If for some reason you had to know that, you should know how to figure it out. But I don't really need you to memorize all that stuff. Okay, you should also know the product, the quotient, and the chain rule. And these I will expect you, despite what I just said, to have memorized these formulas. All right, maybe I'll just write them for one time. The product rule says the derivative of f of x times g of x. Again, there are many ways to write this, and if you write it in a slightly different order, that's totally fine with me. But this is, I always do it this way. The first thing times the derivative of the second thing plus the second thing times the derivative of the first thing. That's the product rule for the derivative. There is no similar thing for the integral. If you're taking the integral of a product, it's much more complicated. There's no cute little rule for that. You got to figure it out in some other way. There is also the quotient rule. The product rule is possible to write this in many different orderings, and it's probably the same as what I have, so that's fine. The quotient rule is a little more rigid. You have to get them in the right order because there's a minus sign instead of a plus sign. But this is the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Right? So you should have those memorized. These are actually not going to come up as much because most of this course is about the integral rather than the derivative, but it'll come up every so often. All right, and then the chain rule is about a composition, f of g of x. This actually is probably the most important of the three, the chain rule. And this one, you do the derivative on the outside first with the same thing on the inside times separately the derivative of the inside. So that's the chain rule. The chain rule, actually, I sort of have these memorized more or less exactly the way that I wrote them. This one, I don't really memorize the formula. I just think of it in the way that I just said it out loud. You take the derivative of the thing on the outside, which is the f, leaving the same thing on the inside, and then you multiply times the derivative of the inside. That's how I think of the chain rule. I say those words in my head, and then I write down the formula if I really have to. All right, any questions about that stuff? Great. Okay, one other thing is something that I didn't mention yet is along with these integrals, maybe I should have said this a moment ago, you should know how to handle a definite integral. That's the one with the little numbers. Something like this. The one with the little numbers. How do you handle that? You do it the same way as I did before. So those ones without the numbers is called the indefinite integral. The one with the numbers is called the definite integral. The one with the numbers represents the area under the curve of this function, which I guess is a parabola. The one without the numbers represents the antiderivative, which is apparently, like on the surface, these seem to be completely different things at all that don't have anything to do with one another. But actually, they do have something to do with one another because of what we call the fundamental theorem of calculus. But anyway, the way that I'm going to write this out is I write the antiderivative, which is that, and then I put the little bar here with the numbers like that. This is how I'm going to write a definite integral. Like I said before, if you learn to write it in a different way, that's fine with me, but this is how I'm going to do it. And then this bar with the numbers means I'm in the next step. What the bar means is in the next step, I'm about to plug in the 4 and then subtract and plug in the 1. So I go like so, 1/3 times 4 cubed plus 7/2 4 squared minus 4 times 4 minus, I plug the 4 everywhere for x, and then I go minus. It's always minus here. And then you should probably put parentheses. And then I'm going to plug in 1 everywhere for x. So I'm going 1/3, 1 cubed plus 7/2, 1 squared minus 4 times 1. Of course, you don't really have to write these 1s in there, but I'm just trying to be clear about what it is I'm doing. All right? And that's my answer. Again, I would not try to simplify this unless you have a good reason to. And maybe now you can be a little less concerned about the fact that I said you are not going to use calculators on the quizzes, or like on the quizzes and tests or whatever. I would expect you to just leave your answer like this. So don't try to do the long divisions or whatever. Just leave it like that. If you're ever unsure during a quiz or something, can I leave it like this? You can ask me. Can I leave it like this? And I will say yes, probably. All right. I'm always a little unsure what to say. If you wrote something completely wrong, you say, is this okay for the answer? I guess so. Yeah, if I seem a little unsure, it's probably because you did it wrong, not because I'm unsure about whether you can leave it like this. I really don't care if you don't simplify. So you can leave it like this. All right. How about, would you mind if I give you some to try out? This is something that I like to do. You know, I don't like to stand here and talk a whole lot. I'm going to give you a few. I hope you don't mind. I'm going to walk around and see how you're doing. I don't intend to collect this or grade them or anything. I just want to help. Think of me as a doctor, as they say. Sorry. Come on now. All right. So you try a few. How about These are all fairly straightforward individually. This one here has a little trick that I didn't mention, but I hope you all know what to do. Sorry. And please let me know, of course, if you are can't read something that I wrote. All right, see what you think. I'm gonna walk around and see how you're doing. Let me know if you have any questions about anything. That's what I'm here for. We'll just take a few minutes and then we'll do some more. That's good so far. Yeah.
It's just like, do you see this?
Yes.
That's plus one. That's plus one. And that's plus one. It's just it's two.
So you're gonna leave the one like this. Okay.
Could you explain this one to me?
Sure. Yeah, so after, this is good so far.
Okay.
And then you're going to do something like,
Oh, wait, sorry.
too far. Something like, phrase here, 5x minus 2, or like this.
Okay.
You leave, so you would leave the 5 the same, and then do the 1 this part.
Okay. So
like,
keep the
1
1
8,
okay.
and then
Do the equal, okay.
You doing good now? Good. Still good here? Yes. Can I make a suggestion? That's for
Oh, yes. Excuse me?
Yes.
Aren't all the people in that building in this building, or do they all spread out?
All of our offices are in this building, but some math classes are in the other. Yes. Yeah. Do you need to go see them?
I have a question. I did figure something out. Like the placement and stuff.
Okay. So we could try to talk about it maybe at the end.
Yes.
But yes.
Thank you.
Am I right?
No, I also found, what's it called?
Okay.
Yeah.
What do we even do?
All right. Okay. Can I make a suggestion with this one? Yeah, I think we did the quotient, which is quotient is a derivative. This is right.
Like that's what is. Remember? Yeah. I mean 2x. So 2x minus. Okay. That's it.
You guys still doing good? Yes.
Wait, what are next line? These are all okay. No, I can pass. Yeah.
Sure. Yeah. Yeah, just
Do it really next to you.
And then it's when you use like
You add.
That is just simplify. You cross choose that.
Yes. Yep.
And then we just
The four needs to be All right, can we talk about these? I know not everybody is finished up, but that's all right. So the first one. Okay, the first one. Come on now. This one you should just go. So I'm going to rewrite the inside first as 1/8 x to the minus 4, and then do the integral of that. The 1/8 will just stay like it is because it's a coefficient, and then the x to the minus 4, you do the thing with the power. So it becomes 1/8, and then 1 over minus 3 x to the minus 3, plugging in 7 and 3. You can multiply if you want, 1 over negative 24, or just leave it like that. I'll just leave it. 7 to the minus 3, and then subtract. Same thing. 1 over negative 3. 3 to the minus 3. 3. Like so. There you go. That's what I got. Any thoughts about that? If you wrote it slightly differently, it's probably okay. But that's what I said. All right. Let's try this one, which is now at the bottom. I wrote it a second before. This one, I saw actually a lot of creative and wrong answers to this one as I was walking around. First of all, you should not use the quotient rule, even though I see a fraction here. The quotient rule is used only for the derivative, so that's not appropriate in this case. You also cannot just sort of go through the top and also go through the bottom and do the antiderivatives. You have to handle this somehow. Anybody got an idea of how we should, yeah?
So you would split up x over 2, or x to the second over x to the fifth, minus 7 over x to the fifth.
Yeah, great. So this is a simplification. Actually, it doesn't look simpler yet, but it's going to be fine. Like so. And then each of those you can simplify by like subtracting the exponents, right? The first one becomes x to the minus 3. Still inside the integral sign. X to the minus 3 because I subtracted the exponents. And then the second one, that's just 7. And then I write the bottom as a negative exponent. So this is like so. So that's how you have to rewrite this one. I'm not done yet, but now it's in a format where I can just do the integral as the next step. Now this is great. Another way that some people like to write this, which is you might like this better, and it's like I say, totally fine if you want to do it this way also. You could also, some people did it this way as I was walking around, bring the denominator up as a negative exponent and then distribute that across the thing in front of it. Distributing by adding the exponents, and what I end up with is, first of all, x squared times x to the minus 5. You add the exponents, you get x to the minus 3, and then minus 7x to the minus 5. I wrote it right. And this is the same as that. So those are two different strategies which get you both to where you want to be is just something that looks like a polynomial, right? A bunch of powers of x added together. If you have other stuff in there, multiplication or division, you got to rewrite it somehow. Okay, anyway, either way you want to get there, from this point we just do the integral. So I'm going to say 1 over minus 2x to the minus 2, right? The negative 3 power becomes increased by 1. And then the negative 5 power increases to negative 4. So this becomes minus 7 times 1 over minus 4x to the minus 4. And then my plus c, like so. Hope you got something like that. Any questions about that one? That's a little tricky. This I don't know. It seems like some people forgot how to handle this kind of a thing, but that's how you do it. All right, great. And then the last one about this sine x. Let's just go for it. The integral, the 4 there doesn't really matter for much at all. It's just a coefficient, which is just going to stay like a coefficient. So the 4 stays like it is. And then the integral of sine is negative cosine. So you can write 4 times negative cosine, maybe minus 4 cosine of x, right? Evaluating at pi over 2 and 0. And I suppose I didn't mention this before, but I do expect you to know the various values of sines and cosines. So when I say you don't have to simplify anything, that's mostly true, but if you are plugging in these sort of ordinary values of sine and cosine, I would expect you to know what those values are. So this one is, well, let me just write it first. Negative 4 cosine pi over 2 minus negative 4 cosine of 0. And then I hope that you all know the values. Anybody remember what's cosine of pi over 2?
0.
It is 0. Yeah, cosine of pi over 2 is 0. Cosine of 0 is 1. These are, you should know the various sort of unit circle type values of the sines and cosines. You may want to do some review of those if you have forgotten. Anyway, this is negative 4 times 0 minus negative 4 times 1. And if you simplify the signs there, it's just 4 at the end. All right? Any thoughts about any of that? Great. I think that's all I wanted to say for the first item on our big checklist. Simple derivatives and antiderivatives. It's a deal breaker, folks. I hope that you already know how to do this. You may have to review some of your techniques. Remember, the deal breakers, you have to get at least 2 out of 3 points for. I know it's easy, like, even if you completely know what you're doing, it's easy to just screw up a little thing and not get full credit for that reason. But you got to get 2 out of 3. All right, we have about 15 minutes remaining. Maybe we can just start with a little introduction to the next thing on the list, which is the U substitution. The U substitution. This is a trick for doing the integral, and it's based on the chain rule, but you don't really use the chain rule when you're doing it, although the sort of theoretical underpinnings of it, the U substitution works because of the chain rule. But this is an integral trick. Many of the things that we talk about in this class are various tricks for doing the integral. There are many, many tricks for doing the integral. The U substitution is the only one that I'm going to assume that you've seen this already, which is why this is a review topic. So it's an integration trick when we see, this is the usual application of U substitution, is when we see stuff inside other stuff. That's the typical situation in which the U substitution is the appropriate trick to use. Stuff inside of other stuff. So, for example, this is an example where you would use the U substitution, something like that. I have some stuff inside of that exponent to the 12, right? Now, if you didn't know the U substitution, you could, in theory, you could actually expand out this to the 12th power. That involves like doing the FOIL thing 12 times. This would be a nightmare to actually do, and you definitely should not try to do it that way. But in theory, you could do it in that way. Expand this out. It would end up being a 12-degree polynomial, which you could then do the integral of. But this is a real pain. Instead, the trick here, so this one here, this is, I will say, hard as written. You don't want to actually do that 12th power, although in theory you could do it. This is hard as written, but instead you want to realize it's just like something to the 6th power, which, not 6, 12. It's just something to the 12th power, which ought to be easy, right? It ought to be whatever to the 13 and then divide by 13 in the front, because that's how we handle a 12th power. So this is the idea behind the u substitution. It's just something to the 12th power. So the answer ought to be, 1 over 13, whatever, to the 13, right? I'm just saying, it's some stuff in there, right? So the answer ought to be this. Now, is that actually true? It turns out actually the answer is, technically speaking, not exactly equal to that, but it's close to that in a way that you can easily sort of compensate for the difference. But that's the idea behind the u substitution, all right? And it's based, like I said, it's based on the chain rule. So the chain rule for the derivative, if it's the derivative, if I was doing the derivative here instead of the antiderivative, the chain rule would say I put 12 in front, I go 5x plus 2 to the power 11, and then multiply times 5. That 5 comes from the derivative of the inside. All right. The chain rule says if you have a 12th power, you really can just do the derivative of that 12th power, but you got to multiply times the derivative of the inside. All right. For the u substitution, it's this same idea. You do the antiderivative of this stuff, but you got to, instead of multiply times derivative of the inside, you got to divide by the derivative of the inside. That's the idea of the u substitution. All right, so to do this for the integral, let me just write. This right here is the chain rule times the derivative of the inside, right? That's sort of what the chain rule means. You know, if someone asks you in the club, what's the chain rule? Your answer should be something like, you got to multiply times the derivative of the inside, right? They love that in the club. For the integral, it basically works in the same way, but you divide by the derivative of the inside. And that's called the u substitution. We don't call it the chain rule, even though it's based on the same idea. So for the integral, we must divide by the derivative of the inside. All right, so it turns out, and maybe I'll just leave it at this. We'll do some real examples, but for that one that I've been writing all this time, if you do the u substitution correctly, the answer here is 1 over 13, 5x plus 2 to the 13. Oops. Times 1/5, because this is dividing by the derivative of the inside. Or you could say divided by 5 if you want, but it's a little easier to write, times 1/5. All right? Now, this is an easy example because the derivative of the inside is a constant. It doesn't always work out that way, and it sometimes gets actually quite a bit more complicated than this. This is an especially easy one. But maybe we will leave it at that for now and get to more of this next time. I would be happy to chat with anyone. If you're unsure about like what math class you ought to be in, please let me know. I'd be happy to talk about it. Or anything else, let me know. Otherwise, I'll see you tomorrow. Hopefully the clock will be better.